some kind of priority to decide which ones get to allocate first is the way to go. And this will allow us to fix the backtracking problem. So summary, there's a lot of work to be done. We want to do smarter fee elimination for faster compile. We want to kill off backtracking by using iterative approach. We want to improve maintainability by insert spilling on the fly rather than wait until the end. This removes much work the rewrite has to do. We want to put a lot of effort into improved spilling. We want to be able to split iteratively in arbitrary places. We want to use availability information and alias information to do really aggressive rematerialization. And we have some other crazy ideas we are thinking about, such as rescheduling to reduce register pressure. And that's the end of my talk. Questions? Yes, we do. So the way we do we do restoration on x87 stack? Yes, we do. We basically have pseudo register class that represents the x87 registers like normal registers, which means random access. Then we have basically turn that into stack operations in a later pass. Yes.
Are there any special considerations for vector registers?
Are there any special consideration for vector registers? No, we treat them just as normal registers. Yes.
Is there a point at which you're working so hard to undo all the work you've done before that you might be better off having the other stages more integrated?
Is there a point where we're redoing all this work that it's better to integrate all the works into the REST locator? Are you talking about the interaction between the REST locator and the spiller? There is a possibility. For example, it's possible to fold some of the to-address computation into perhaps coalescing or the phase that deal with life interval kind of computation. A lot of things can be folded. Yes, the current structure serves well enough, so we're not actively working on it.
You're saying that currently the selection tag sounds like optimized is trying to choose to reduce register pressure for the register allocator. Is that something you'd like to be able to remove if the register allocator was?
I don't think that's quite the case. There's only so much the REST locator can do. So
maybe can you say something about why that's different? Why does the register allocator, the tag selection rather than need to preview some of that?
So the scheduler actually does try to reduce register pressure for x87 where the register resource is extremely constrained. So the register allocator can't really deal with, can only do so much. So there's a trade-off of scheduling for latency and there's a trade-off for register pressure. We found from our experiments that for the more modern x86 implementations, scheduling for latency doesn't really offer all that much. Okay, there's the kind of dynamic scheduling engine in the CPUs work well enough. So we concentrate on reducing register pressure.
Does the graph coloring approach to register allocation take too long or produce worse results?
My personal opinion is no single heuristics algorithm is the best. It's all sort of in the implementation. So we put a lot of thoughts into the implementation details and do all these optimization to get performance. The graph coloring, there are many.
For example, we can have light intervals on AR and 100 Hz. So they need to be complex.
So the question is about sub-registers like AL, AH. Can they kind of are we taking advantage they don't overlap? And so we are somewhat conservative in that. So a lot of cases, but we do check if two physical registers overlap. If that's the case, we know that. So the REST locator is taking advantage of that.
questions. First, you mentioned that you do this value numbering for well lessening. So is that equivalent to providing insurance for that project? Not for
In a way, right? Because we have, with help of, yeah, basically, yes.
So
Yes.
For example,
So.
sequence of copies all from the same register in the register, roll out the first one, you still don't consider it interfering with
Right, right. So basically the question is whether value numbering let us not having to build an interference graph. That's part of it, right? That's right.
Okay. And the other question, so for coming back to the vector question, so one issue that arises with vectors is you have multiple writes. You can have dependence on vector before. Do you do anything to choose registers based make register choices that are far away, so you prefer small dependencies?
The question is some vector operation can implicitly write update parts of the register. Therefore depend on early operation. So we do live variables analysis time. We pay attention to a lot of these partial dependencies if they are explicitly represented. So I'm not clear on whether we do enough of that. As far as the rest allocation goes, we don't do enough of choosing this register over another one. There is a way to define the order of allocation preference, but that's sort of kind of my idea of what's best in a lot of ways. So you can ask me a question offline. Thank you.